Okay, welcome everybody to Robot Builders Night Virtual for November 19th. And we'll have the usual agenda, preceded by a discussion of logistics for Saturday, and just make sure we have a plan. We all know what we're going to do. And then we'll get to the queue, and then we'll go to open mic. So starting off, let's see. Starting off with logistics for Saturday. And I guess I should have brought up the timetable, but I got an email from Tom and Pat that maybe there won't be a Canada event this Saturday. Do you guys want to update us on the situation in Canada?
Yes, so both Tom and myself are still running into problems programming our robots, various different problems. I've run into a problem basically where my serial communication interface is giving me a weird value. So something that's been working for years, I haven't had an issue with it, all of a sudden started, it's returning a value, and it should be 0 because that's what the program is telling it to send.
Well, maybe we could dive into the details later of what's going on during your update. But really what I'm trying to get to is, it seems we talked about maybe doing a virtual co-run kind of thing like we did for the Roborama, but that's got some challenges in terms of getting video streaming and recording and live and all this kind of stuff. So what I first of all want to get to is, do we need to consider trying to factor in a remote Roborama in some kind of co-run manner?
I would say at this point, no. I don't think Tom or myself is ready to go. So since we were the only 2 competitors, I think that the remote video option is pretty much null and mute at this point.
Okay. Sorry to hear that, by the way.
That's all right. Canada is going to have to default on this competition.
Well, okay.
But what you could do is do like tonight and talk about how the robot is doing or something for a little bit of the time, right?
And I guess there's nothing to stop you from running it on a different day if the weather looks more favorable.
And if the computers look more favorable.
If the robot gods have smiled upon you a little later.
Yeah.
You guys can
I know myself. I've pushed off some work. So I owe my wife some work, and I owe my boss some work. And unfortunately, it comes a point where I have to call and say, okay, it's time to set the robots aside for a little bit and start focusing on other things. So my wife has been very generous in the amount of time that I've spent working on this, as well as my boss. So I've got to sort of get back to a wife-work balance.
2 bosses is pretty difficult, Pat. So.
Well, hey, she's number 1, and my boss is number 2. So.
Well, yeah. And my wife's been very understanding as well. I've been relieved of almost all chores, and I got ready for this competition. So, but I certainly recognize the priorities, and sorry it didn't work out, but you've got a pretty cool looking robot. So next year, maybe.
We've been trying, both Tom and I have been trying, like, I know, working our brains off, trying to get everything up and running. And it's just the amount of stuff you have to get done and working and tested to pull off even 1 point on this competition is phenomenal.
Yeah, it is.
Yeah, I get it.
And hats off to you guys that have done this. We watch the videos every year, and I'm very impressed. Even with the failures, I'm impressed with how far they go before they get caught up in a shrub or something.
Yeah, it's a challenge.
Yes, we're realizing firsthand just how much detail goes into this problem. And of course, the frustrating part is it all works great in the house in my workshop. It only breaks when we go outside.
Yeah, you do the first 90% and then you have to do the second 90%, right?
Or it works great at 11 o'clock at night when I'm working on it, but then when I take it out in the sunlight, it doesn't want to work at all.
Sorry, I joined late. What competition are you talking about?
So hi, Pavel. This is Paul Bouchier. I'm the president of the DPRG. We're talking about the Robo Columbus competition that is happening this Saturday. Would you like to introduce yourself? You're new to the group, and welcome. And we'd love to hear how you found this and what your interest in robotics are.
Sorry, I missed a little bit that but so yeah, I found you guys on Meetup. I was just looking for like some sort of robotics club, because I just moved to Omaha from Oregon. And so
Okay. Yeah, we are a robotics club. We're centrally based in the FW Metroplex, but we've got a sizable contingent in Canada and various other members spread around the US. I'll tell you what. Let us just finish this discussion on Robo Columbus planning. But if you go to DPRG, while we're doing that, Pavel, if you go to dprg.org and under competitions, you'll find Robo Columbus 2024, and you'll find a description of the contest there.
I put that link in the chat.
Thanks, Steve. Okay, Carl, I think you were in charge of communications, videoing. Last year, did you have an online broadcast, and what were you broadcasting if you did, or what's our practice been here? I guess you or Doug could climb in here.
I think we've had a mix. Well, we've had like separate device camera or camera phone recording running around, and it's captured and mixed later. But for when we know that we have people would like to participate remotely and to dial in, Steve has some nice infrastructure there. So we've set up a streaming web service just like this, and we've recorded what we can. And I think at times we have even had the phone logged into the Meet to stream it that way. But what we've had available is kind of dependent on who's there and what they're doing and how much battery there is and what there is to see and who wants to be on the other end. And I think we have enough. In the past, I think we had a lot of planning in the past, and in the last year or so, we've just kind of winged it based on what we know.
Paul, we try to capture an interview with everybody on the robot. That's usually recorded. It's also, that's kind of easy to stream to at the same time. Do you know what I'm saying?
Yep.
And then we try to get all the runs. Now, there's probably somebody running around with their phone capturing the runs that's not on the meeting. Okay. And then there's probably somebody on the meeting who's not really he's watching the same robot from a different angle because it's a different person, but his focus is being on the stream. Do you follow? So one guy is trying to just record a video, and the other guy is trying to record and stream. And hopefully, out of the two of them, we can get every one. Now, like last year, we missed one run. Okay, and I think that was a battery situation. But you know, so somebody will have their phone, they'll have it shared, and they'll just be running around, you know, whatever's going on. You know, there's a lot of woo 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 going on during the competition. So that, you know, that's kind of what it goes.
So do we need to organize anything in advance, or should we just wing it when we arrive and see who's got what phones and what they're willing to do?
I've got cones and I've got tennis balls. So that part's done. Steve, do you still have some marking paint?
Some marking paint. Yeah. I'll have the marking paint, the string, you know, to measure the 10-foot parameter.
Yeah.
Yeah, that'll be ready to go.
That's, you know, that, and, you know, like you said, you know, somebody has to have a laptop with the meeting going on.
Yeah.
Yeah. So I'm thinking that's that, and just, you know, breaking for lunch, which is very important.
Carl, will you bring your laptop?
Yeah, I was actually updating it now, so I can bring a laptop for streaming.
Okay.
And recording.
And then the phone, I guess, Doug, Carl, your phones work?
Anybody.
Well, anybody, like I say, we'll try to do, you know, I'll have my phone and I'll go as long as the battery will last.
And cables, I assume you have enough, Steve, or do you want
you should bring your own power cables. You should bring your own table, and it's not a bad idea to stick in a chair. So having and if you need a display or anything like that, then you need to bring your own. You assume that you're setting up in the field by yourself. Don't count on anything from anybody else. But you know, we'll all, you know, like I usually bring a little toolbox. So like if you need a screwdriver, you can, and I usually keep a selection of screws and nuts. So there, you know, there's some sharing going on, and I always never get the right USB cables. You know, I'm always missing one. You know, I think I got them all and to find out. So, but the big thing is having power, because Steve has some outdoor outlets, but you know, he's not going to try and provide extension cords for everybody.
I've got a few, but yeah.
Yeah, that's really your own.
Bring what you think you need, if you can. If not, I've got a few.
Yeah. I'm trying to think. Steve, was there anything else that I mean, that's pretty much it, isn't it?
Pretty much it. I'll supply some sort of breakfast food in the morning. There's a kolache place I'm interested in trying that I haven't tried here nearby, and then I'll make sure pizza arrives whatever time you guys want to eat lunch.
Yeah, sounds good.
Great.
And maybe some drinks.
Yeah,
Steve?
Drinks and waters for sure.
Yeah, we drank a lot of water last year, I remember.
Last year was hot. This year is not going to be as warm. So
it looks like it'll be lovely on Saturday.
Should be very nice.
High around 70. So I guess things get started in terms of laying out the course around 9.
Pretty early. It's 9, I think, is about right.
Yeah.
And we, you know, we try to make sure all of the waypoints are right and everything like that. You know, and like I say, everybody's, you know, if they want to check the waypoints, they can do that too. So let's see, anything else? I'm trying to think. That's about it.
Okay.
It is very, very busy. it's very, very hard to compete at any level and be working the competition.
It is.
Yeah, so
And,
you know,
and you're the master of the competition, Doug.
well,
So
I'm just saying, right now, I'm just going to say, I have buttoned up my robot, but that code base is still sucks. So I'm hoping that on Saturday to at least be able to roll down the hill. We'll see how it goes.
maybe you want to, like, as the need arises or the opportunity arises, assign people who may not be intensely working on robots or whatever to help you out with different things.
Well, the main thing is the videoing, because in the end, you know, you learn an awful lot by reviewing the videos. In the moment when you're doing it, you have no concept of what's going on. You know, your robot's running, you think it's doing something, but you really don't have any idea. But later on, you can look at that video and you can say, "Oh, that's not good."
Yeah, I was tremendously appreciative of the video of my runs.
Yeah. So, and with Ted's tennis ball idea, you know, I really don't know. Oh, there is one thing I should say. They're brand new tennis balls this year. So I wrote the rules up. I changed the rules slightly a few weeks ago, where the tennis balls are in good condition. So they don't have to be new, but this time they're new. Because we're going to use them next year. The cones, some of them are more older than other cones. So we do have slight variations in the color of the cones. Just so everybody knows that up front. You know, we have the new cone, which is bright red or what are bright fluorescent. We have the old ones that look like they've been out in the sun too long. But so we'll just have to go.
I've got a near new one that I can contribute.
Yeah. So anyway, yeah, I think even, you know, so I think that's we're in good shape there.
Yeah, it sounds like we don't have to do too much like organizing and getting people assigned to things. We'll just
yeah, if everybody, whoever's there, you know, who can help, you know, jumps in, that's all we you know, there's going to be some spectators that show up. Hopefully they can be pressed into service.
Yeah, Mark Reynolds was going to show up, so
yeah,
that'll be good. And Trish, the VEX competition lady that joined us one evening, is going to be there as well. So hopefully we'll have some extra hands on deck.
Yeah, just somebody to, you know, because like I say, it's really, you know, if you're competing and you really want to be hovering over your robot.
Exactly. And when you're not competing, you're looking at the code to try and discover why it did whatever it did on the previous run.
Well, I've given up on that. If you don't make it in your first run and it's not something really trivial, you know, the code base doesn't change. You just say next year, which gives me another idea. If there's enough interest from our Canadian people too, they might, you know, maybe in the May or June, whenever is a reasonable time, we can have a midterm Robo Columbus, because that, you know, like, you know, you always feel like if I only had 2 more months, I'd be able to do this. 2 more months, you know. But what happens is, you know, for 2 months you wander in the woods, and then on the last day, you know, you have these eureka moments like, oh shit, I'm screwed. You know. So anyway, we'll see how it goes. Man, I wish I knew something about.
I'd like that, and maybe earlier as well, because X Games is on in San Francisco in April, I believe, and I'd love to go with the new robot, but I don't know if if I'll have a new robot.
Well,
that's
I think,
working on
I want to say Robo Magellan goes in August,
September.
maybe. Yeah, somewhere in that time period. It's
Yeah.
before,
Yeah.
So
Okay. Any more discussion on Robo Columbus? Thoughts?
Oh, I just wanted to say for anyone who missed it last week, I announced that I'm not coming.
oh no.
Yeah.
No, I did miss
Oh,
it.
missed you.
My robot, it's working about as well as usual, which means it could make it to the first cone. But the real problem is I've just got too much going on right now. And I did a bunch of driving this year, and I just can't stomach the idea of driving to Texas over the weekend and trying to make it back, all in 3 days. So, yeah.
Yeah, I know that is tough.
Sorry to hear that, Ted. I was looking forward to meeting you in person, but
Yeah.
I understand.
I've been trying to figure out how to psych myself up to make it work, but it's just not a good time right now.
There comes a time, Ted, and it's okay. It's
Yeah.
Yeah. Yeah.
Next year.
Okay. Anything else on Robo Columbus? Let's see. If not, let's see. I'll just ask. So we had a new person join the call, Pavel. Did you have any questions for the group, Pavel, or anything we can tell you about the club? Or do you want to tell us? You said you just moved from somewhere to somewhere, but I didn't catch where.
Yeah, I just moved to Omaha, so I guess I was wondering, have any of you guys competed in any of the competitions like up in Washington?
No.
Okay, I know they have
we have had members that have competed in it in the past a long time ago, but not recently.
Okay, yeah, 'cause I was wondering.
That's one of the things we want to do.
Yeah,
Okay.
there's a couple of us, at least 2, maybe 3, that would like to go up to Washington and maybe out to the Bay Area for to try and get some broader exposure to their contests.
Okay, yeah, because I was gonna say, I don't know if you guys have heard of the one up in, I think it's up in Washington. I forgot what club it is, but they have one where you have to get like a soda can out of a refrigerator and then bring it back to the starting point.
That's the Seattle Club.
Yeah.
Society of Robots.
So just to orient you, we and many other clubs have an outdoor competition and an indoor competition at like different times of the year. Our indoor competition is in May usually, and outdoor is in November. And so they're completely different contests. And so what you're referring to there is an indoor competition, but the Seattle Robotics Society also does an outdoor competition, which is similar to ours, where robots have to travel 100 yards over rough terrain, possibly somewhat rough terrain, not too terribly rough. Yeah. So anyway, we want to do that. Several of us want to do that. But
do you guys use a lot of ROS also, or are you guys not too much into that, or?
It depends. Different people are and others aren't. So I'm heavily into ROS. My robot is, the autonomy layer is completely ROS based. So there are a couple, 2 or 3 or 4 other group members who are heavily into ROS. Others tend to go the microcontroller and subsumption architecture kind of route.
Okay. I guess sorry, yeah. So last two questions, I guess. Do you guys like I guess if I wanted to like maybe join somebody to work on one, do you guys have any like members of the group that maybe need any other people to like help work on a robot? And then I guess second question, do you guys do like any like learning things during the calls too? Where like somebody does like some like teaches about something or anything?
So two questions there. Do we have learning opportunities or people teaching about stuff? We do most month. We have a monthly meeting, the fourth Saturday of the month. Most meetings we have a speaker talking on some topic related to robotics for typically an hour long presentation. We have in the past done various more teaching oriented events, like Ross, like building your first robot, variety of things. Do we have, is anyone interested in collaborating, or do we have collaboration platforms? So this meeting is the get together and talk about what you've been doing, what you've discovered, what's new in the world of robotics, etc. We have a email list and a Discord server. The Discord server is where a lot of very technical discussion happens. And if you want to join that, I can send you a link to it. And you're also welcome to join the mailing list. It mostly just gets meeting notices and the like transferred across it. As far as someone helping you build something, most people tend to build. Well, there have been some various collaborations that have happened. They've tended to be organic. You'd probably want to put the word out on one of the communication channels and see if you could find a match for whatever it is that you're trying to do.
Okay, cool. Yeah, thanks. Yeah, if you can send the Discord link, that would be great.
Okay, can I ask you to send an email to president@DPRG.org, and they'll come to me. I'll link you into the Discord server, the email list, and we also do record all of these calls. And if you go to our website, which I'll share right now.
And can you send? You said president@dprg.org. Okay, that's it. Okay, cool.
Yeah, and on our website, on the homepage, if you go under news, you will find videos of all of our monthly meetings and these Tuesday night meetings. Hopefully I'm sharing that.
Cool. Yeah. Thank you so much.
Yeah, but drop me a note and I'll send you links and get you on the mailing list and so forth. Okay, well, welcome, Pavel, and I hope we see you some more, and look forward to any contributions to the group that you may offer. Everyone's welcome here, and welcome to tell us what they're working on and what interests them and what they're trying to achieve. And the first section of this meeting is a roundtable with people describing what they're doing and what problems they're having, and the club the club members try and help out where they can. Okay, Pat, you're up first.
Okay, well, as I alluded to earlier, I've been having some troubles
getting my serial communication, which has been working very well for years. It started sending me a weird value for my velocity. I'm sending out a 0 and I'm receiving 12,336. And that's happening all the time now. I get the value, I can confirm the value in my Redis server is 0. And when I try to run the robot, since 12,336 is more than 400, it runs the wheels at full tilt in the forward direction with no ramp up. So basically just goes full up and runs. I know my Python code sends out a slew to ramp up the speed. And when I read the serial string, for whatever the reason is right now, I haven't figured it out, I get 12,336 as my linear my linear velocity.
Is that the only thing you're sending over that serial link?
I'm sending a it's a 2 value string. I'm sending it serially. It's like a list, and I parse them out to 2 integers. So out of that, I'll get basically a command velocity and a command rotation out of that.
Are either value correct or just getting garbage?
It's my other value. My rotation is 0. So it's my velocity that's coming through at 12,336. And I've got it hard coded so that when I send out the value, I send out a 00 to serial send.
Hey, Pat.
Yep.
12,336 in hexadecimal is 3030, which is an interesting number.
Yeah. So
I'm wondering if you've got some hex value. Well, I guess that wouldn't be space.
It's a 0. Hex 30 is a
It's a 0. Yeah, there we go. So you're interpreting hex as binary, or you're interpreting ASCII as binary.
Yep.
So that's what's going on.
Good catch, Ted.
Yeah.
It's my job. I always convert everything to hexadecimal and look at it.
Clearly, the right answer should have been 27.
Yeah.
So it's a hexadecimal representation of a ASCII value that is sending over.
Yeah. Well, it's sending over ASCII 00, and you're interpreting it as binary.
Yeah. Okay. I'll get back at that then and see what I can find. I tried to verify that I am sending it as an integer, and something is preventing it, so it's still coming through as hex or as ASCII and being converted to an integer. So thank you very much for that. I'll carry on with it. At this point, as I discussed with Tom earlier today in a couple of emails, I won't be ready for the competition. And so it's about a 5-hour drive to where Tom is to get together for this. So it's going to be an overnight, at least one night. And I said, I'm not ready. So I think I'm going to pull it in. Well, so I like the idea of a May competition.
Well, at least we have an excellent course location and it's ready in advance.
Yes, it is. It's ready. Tom's going to cut the grass, make sure it's cut for it. So May 2025. Well, that's it for me, basically. I really appreciate that, Ted. I tried to look at that, what it was doing, and I couldn't make heads or tails. I was coming up with 48 for some reason.
Oh, 48's the decimal version of that, but
yeah, I come up with 48.
So May should have grass, not snow then, right?
Possibly.
Possibly.
Yeah, usually May, by mid-April, everything's gone. Most of the snow in this area or south is gone.
Okay. Well, stump the club. You didn't stump the club, Pat. So
No, and I'm very glad he did not.
yeah. So let's move on to Tom.
Okay, you've heard me talk in the last month or so about all the work I've done on my experimental sensor array and all the work I've done on getting wheels to turn properly, including replacing the entire chassis last week to solve that. So I thought you might want to know that my robot can actually go outside. So it is an outdoor robot. So I put together a simple wander function, which is intended to test the sensors from a collision detection and collision avoidance point of view. So I'll show you a brief video demonstrating that. Let's find that video here. You can see my robot. We'll start this. So it detects the wall and it stops in time, which is good. Avoidance strategy, detects another wall, although not quite soon enough. It just touches the brick. Now it's going to back up. Then it's going to back up again because it detected the edge of the grass. It's not supposed to do that. And it proceeds on its merry way. So it actually runs outside. It actually does something useful. The collision avoidance stuff was a strategy that's required in order to have some basic collision avoidance for path navigation, which I then started to work on. Path navigation for this outdoor robot is, at this point, is based on very simple GPS path navigation. My GPS stuff works reasonably well. My compass is working reasonably well. I have motors and steering that are working. So I put all that together with a very simple GPS path following test. Basically one waypoint on one corner of my backyard, put the robot in the other corner and push the button, and it's supposed to find its way to the waypoint using GPS and compass. So it proceeded to merrily drive away with the compass steering logic working fabulously in a seriously wrong direction. So I'm thinking, well, I can fix that problem, right? So then I went and stopped it and had a look. And I have a display on board that shows some relevant variables. And the distance variable that says how far it has to go was also some ridiculously wrong number as well. So I thought, well, that's only one test. So pick it up, put it down in a different spot in the backyard, same waypoint, a different starting location, and see what happens. This time, it did nothing. It just sat there. So I went over to have a look and see what was wrong, and the display says, "You're already here. Distance to go is 0." So scratch my head, go back in the house and think a little bit, and finally recognize that the use of single precision math in MicroPython on an ESP32 doesn't cut the spherical equations I'm using to compute distance and bearing. I'm using the Haversine equations simply because I've used them before. They worked fabulously well on an Arduino running in C with double precision floating point. Just really, really works well. It's a standard solution. Not so standard on single precision, unfortunately. After I did some testing and some lookups, not good enough. So that leaves me with a number of scenario solutions, which I've started to look at. One of them is to see if I can put together a MicroPython that works in double precision floating point. The problem is there aren't any standard provisions for that for any of the microcomputer boards that I have available to me. They simply don't produce it, although it's possible. And they do provide instructions. If you're really talented, you can roll your own version of MicroPython with double precision floating point. I'm not really prepared to do that. It's a complicated process. So what I will probably do is look at extracting the GPS coordinates from the driver piecemeal rather than as single floating point numbers, rather than as normal decimal latitude and longitude. Extract them as components in a tuple so that they don't overflow the floating point numbers, and then convert them using a local origin to a much, much smaller number, which I can then use to perform traditional two-dimensional Euclidean geometry in order to compute path following. That solution looks relatively straightforward. The only complex part is whenever you go out to the field, you pick a local origin in order that the conversion math has a local origin, latitude and longitude to work from. So I think that will work well. I've sketched out the solution already. It'll be just like building an indoor path following robot with really, really big numbers. Probably work with centimeter resolution. And I've already had some of that code running last year's exercise with an indoor robot. So that'll be the solution I'll use. Of course, taking the robot outside leads to discovering a few other things that don't work as well as they do indoors. So I still have to do something to deal with the fact that I have no speed regulator on the drive, and therefore using simple throttling to provide speed selections really isn't a good solution. So one of the choices there is, since I have a 6 degree of freedom IMU on board the robot that I'm not using for anything, I will probably take a look at whether I can derive a reasonable estimate of velocity from the IMU, and see if that's useful. I'll also derive yaw information at the same time and use it to fuse with the compass readings, since we don't have tilt compensation working on the compass yet either. Anyway, those are some of the interesting learning opportunities ahead of me in the next few weeks. I posted some of this stuff on the Discord channel this afternoon in case anybody wants to look at some more of the details and has any suggestions on other things that may help solve the problem. I'd certainly welcome any input.
I guess you haven't read my response yet.
Not yet. No, sorry, I was out for the evening. I'll have a look at it.
Yeah. Habersign does not work with low precision for short distances, as you've already discovered.
Well, it certainly doesn't work with single precision floating point.
Yeah.
Yeah, I've used it before on another project a few years ago, and it worked very well, but different computer, different compiler.
So much.
But I posted a Python flat Earth approximation for you there.
Hey, good, thank you.
Yes, I have seen jaggies on graphs of UTM easting and northing where it got very big but was in single precision, and you see like a meter jump in the path.
That proves the Earth is flat, right?
Within 10 kilometers, anyway.
Interesting.
No, I must admit, it's been an interesting discovery. I've learned more than I ever wanted to know about how single precision floating point standards work.
Interesting. Very interesting, Tom. Well, you should be able to.
Circumference of the Earth, too.
Yeah.
Yep. So more work to do, but it's fun.
Cool. Let's see. I was going to go next in the queue. I had something to share. Let's see. A couple of things to share, actually. Oops. Window there. So, are you all seeing this video?
See it loading.
So, Mobot, I'm happy to say, is doing quite well. Amazing this far before the competition, certainly not like last year. But I would say it's completing about maybe 3/4 of its runs successfully in terms of touching the cone. But with 3 cones to touch and a 70% chance of each one hitting, you end up at about a 30% chance of hitting all 3. But then you got 3 goes at it, so you know the math can help. So anyway, this is going into the stopping within the 10-foot radius circle, and then my bumpers seem to be working really well. I did try it with a tennis ball on top, and it only dislodged the. You see, it did actually move a little bit, but the tennis ball didn't fall off. So I assume that's okay. Is that okay, Doug?
Yep. That's why we quantify it.
Yeah.
Quantize.
I like that. Yeah. So
does that mean you can push it really slowly, 100 yards?
If you can do it without the tennis ball falling off.
Then we're good.
You won't do that in my yard.
Is it that you earn points with the tennis ball staying on, or do you like lose all points if you knock the tennis ball off?
No, the tennis ball falling off just adds to your run time. It's not a horrible thing, but the intent is to keep people from just slamming into the cones. If you knock the cone completely over, it's a pretty good penalty, because let's put it this way, it's a penalty that becomes more important the better your competitors do. For example, if you have 3 people who got 9s, which could happen, then time is going to be the decider. So if you knocked off 3 balls off of your cones, you took 3 penalties, you're probably going to lose a place. And you could even come in 4th. We've had a couple of heartbreakers where a guy came in 4th,
All right.
But if nobody does very good, it doesn't really matter very much. You know what I mean?
Nice. It's a clever, subtle scoring trick.
Yeah.
Although I'm thankful that the rules are still not to the level of FTC. That would just be over the top.
But unfortunately, there's no way to get negative points, huh? Just negative time.
If you achieve a task, you get the points. And there are easier points and harder points. There is a strategy where you go from the home cone to the target cone and back to the home cone, but that also limits you to only 6 points. But if you don't have any obstacle avoidance and you can't find a good way to do your intermediate waypoints, then that might be a strategy. So, I mean, there's a lot of, the game, there's enough flex in the rules that you can game some stuff. But if the better people do, the less that's going to be effective. Oh, God, I wish I knew Python. Guys, I've got a problem. I have an object, and I think it is a JSON object. Okay, and I can't get to the elements, and I go up and I look on the examples on the web, and everything they suggest doesn't work. And I'm wondering.
Put it up.
Okay, well, okay, I'm going to say something that, okay, I'm going to show you some, I'll put some stuff in the chat. Okay. So, okay, so this is supposedly the data structure. Here. Oh, wait a minute. Shoot. I forgot. I'm on two computers. Oh, dang. Let me see if I can join the meeting. Oh,
Hello, can you all hear me?
Yep.
Okay, sorry, my computer went into a load factor of 22 just then, and not sure why, but I ended up closing out of the meeting and shutting a few things down. And it sounds like Doug's fixing to show something.
There we go.
Doug is trying to connect his second PC so they can show us something.
Yeah, it looks like there's some mismatched brackets there. The mask doesn't have an ending curly.
Yeah, it does look. I mean, you can. There's a tool called JSONlint.com that you can use to validate your JSON if you don't have it. I'll put that in. Plus, it's all commented out. Did you intend that? And the width and the height have no values, right? Yeah, that's not a well-formed JSON.
Carl, maybe you could focus on what he did right. So, just kidding.
Yeah. Well, I'm trying to figure out, like, it looks like is it a comment or is there a sample JSON, Doug, or is that what you're trying to compile with? And I don't hear any audio. You're muted.
So I think he can't hear us because he switched computers.
Yeah, I think we need to see where it came from because there would appear to be some typos in there. Not a single one either.
So, do you think he's going to rejoin us?
You send him off into the weeds.
Yeah. Well, while we wait for him to come back, I can, since I went off into the weeds before, I could jump in and continue what I was going to attempt to demonstrate. And then let's do that. So, in my quest for laziness, I attempted. I thought I didn't actually know if Mobot was going to be able to accurately enough navigate to the cones, and it's still not that great or that reliable. So I thought I'd like to have some cone detection, but I didn't feel like I had time to get a neural network going or OpenCV or one of those options. So I looked through the OAK-D Lite and their examples, and I found an interesting example that gave me an idea for how I might do that. So you see the camera showing the cone sitting in front of Mobot, and so I'm going to share. Share. Hopefully it'll work. Window. Okay, so hopefully you're seeing a VNC window on Mobot. And so what I wanted to do was to show yeah. So this example gave me an idea for it. I'm not sure it's going to be real successful, but oops. Oh, yeah, there we go. So you'll see this depth display window.
Yep.
So they've got an example for the OAK-D Lite where there are multiple regions of interest that are all processed on the camera, and so you can see the range there, about 1.4 to 2.4 outside of where the cone is, and you can move the cone and the region of interest reflects reasonably well the range to the cone in that region of interest. So I thought, oh well, here's an easy way to without dealing with OpenCV blobs and cone recognition algorithms or AIs to detect where the cone is and use visual servoing to navigate to it. And I'm not sure if it's really going to work as well as I hoped it would. But anyway, I made a version of that takes a much smaller, doesn't attempt to display anything, and takes a much smaller slice of the image and effectively treats it as a LiDAR, as a single scan LiDAR. And so that is here. So you can see here the cone is represented. It's 0.6 meters away, and the readings on either side are like in the 1.5 to 2.7 region. And so this is a test version not intended to run under ROS. That is just for looking at the image. So it's I found out how to, so I now know much more about the OAK-D Lite, and I know how to set its framework, its frame rate down to 5 frames per second or 4 frames per second, which is what this is running at, and how to crop the image so that the Raspberry Pi has much less to deal with. So this is running on the Raspberry Pi, and whereas with the full image being displayed, the Raspberry Pi was running at a load factor of about 2. Here it was running at considerably less than 1. So yeah, 13.4% of the 12% of the CPU. So that's the Python 3 app is this one. But then when I turn off the video and just output the ranges from these regions of interest, the CPU consumption becomes so small it's almost non-existent. And so I found that I could just run it without having to use the virtual environment. It just ran quite happily. And okay, don't know why I can't find that, but to spell it right. Okay, so that should be going. And then, so the other thing this new program does is it's now a ROS node, and it publishes the depth ranges. So the 10 regions of interest, and publishes them to / depth ranges. And so these are the 10 range readings from the regions of interest. And you can see which one's the cone here, and then the min range and min range in radians is what these bottom 2 lines are. And so if I move the cone, you can see it changes the radians to the minimum range and the minimum range value itself. So that seemed good in the workshop, but then to what Pat was saying, I'm sorry, to what Tom was saying, we get out in the real world and things can be quite a lot different. And so what I found was illuminating, and I thought you guys might maybe be interested. So when I took it out on the lawn, I found that it saw the horizon, and that was sort of, there was a line across the image where the horizon was, and it couldn't really associate the left and right images and calculate a disparity for anything out above the horizon, like it was so far away, skies and trees in the background, whatever. So if the region of interest was above the horizon, which I could do by just rotating the camera, rotating the tilt on the camera, I got all kinds of noise in those regions of interest. It was very unstable, varying from like point something meters up to 10 meters, and just jumped all over the place. So I found the most stable way to run it was to have the camera tilted a bit downwards, to where it was actually looking at the grass, but then the downside, so then you get a stable reading, but the trouble is in the region of interest, it's only about 2.5 meters out. So you don't get very much range for cone detection. But it did look like it was working when it got within about 1.5 meters. You could clearly see where the base of the cone was reading in at 1.5 meters, while the rest of the image was at 2+ meters. So some success on that, but I wouldn't say it was like mind-blowingly successful. So that was my interesting experiment in learning with stereo vision today.
Yeah, I'm using the Pi site instead of actual OAK-D, but you can do with OAK-D. I just basically turn the depth off, save that time, and I'm using, my strategy is basically I have one distance sensor, the TF Mini Plus sensor, pointing straight forward. And so what happens is in the field of view where I spot a cone, I rotate until it's in the center of field. And then I take the distance measurement off the TF Mini. And so that's the strategy that I'm planning to use. But like I say, I can't get the values out of Python here into, I finally figured out how to make the serial ports work, which it changed with Pi 5. So there's some strangeness there, but I finally figured that out. So now I'm, like I say, I'm just trying to figure out how to get this thing to, anyway, my problem.
So I jumped in while you fell off the call, Doug, and I think you were about to show something.
Well, the problem, I found out what happens. Apparently, when I log on my Pi, I log on as Doug Parody. So I end up switching to the Pi. All right. Well, for me, that blows away all of the text, all of the chat. And I have no real good way to bring it over. But so I can't really share it. Yeah, God, I didn't realize that because probably I just dropped off the call because I don't have a microphone on. They don't have a microphone on that camera. I mean, on the Pi. So when I switched to that, I probably just was effectively cut off. So anyway.
Yeah, we lost you pretty much.
Yeah, that's what I figured. So anyway.
Yeah. I mean, if you could point us to the source of that sample code you had and like what the JSON might, well, what the original looked like and where it came from, then we might be able to help it.
Yeah. Well, I'll tell you what, I'll go into the chat and we'll see if it, I can manage to type one line. Okay. This will print it out, but it doesn't get me to the elements. It just prints out the record. Okay. So.
Well, Doug, we did see the JSON you posted in the chat.
Oh, okay. But did you see this? What is this? What have I got here? You know, I look at this as
what are you showing?
Okay, this line will print out the results that
We're not seeing anything, Doug.
I haven't hit the send button.
We're imagining.
Okay, there it is. You should see it. Oh, okay, that one missed a bracket. There's supposed to be a bracket in front of the P. Print bracket. Print. I'll do it again. Oh, so it should be really this. Now, so you can see that it thinks predictions is a JSON object, or at least that's how I interpret this code. Okay. So, okay. So it's a JSON object. Does that work right? Okay. Now the question is, how do you get, so this will print it out. This will print the whole thing. But it's, doesn't the brackets make it a list? Doesn't it put it in a list? That's how I interpreted this. Otherwise, it takes predictions for P in prediction, and it decodes it into JSON. And since there's only one record, it puts it all out there, all in one big bloop. So if you go into it and look at an index, it's 0. It's only if you go to put in 1, it'll overflow. Now the question is, how do you break it up? I often wonder, you know, the people who write these example codes, they're very, very kind of like, don't know how their product is being used. They really suck at it, because they're, you know, you would think that they would say, here's X, here's Y, here's the next part of it, here's the next part of it. So you saw the structure, right? The JSON structure.
Mm-hmm.
Yeah, if you look at it, I think I put it in there, but I can't type it out. It's too big.
Doug, I over in the Discord on the code channel,
yeah,
I took your JSON and I just wrote a little parsing function and showed you how to.
Oh, you did?
Yeah.
Steve, if it works, I'll buy you a beer. Okay. Okay, that's great. I'll go check out the Discord.
Okay.
I'm going to drop off and try it, and I'll come back and see if Steve gets a beer or Steve just gets my. Yeah, right.
Boy,
Steve.
The club's doing great. It's like 2 for 2 so far on Stump the Club. It looks like Pat's got his motor spinning now. Yay.
Whoa. my first guess is somebody knows a lot more Python than I do. Holy schmackerel. It's cool. We'll give it a shot.
All right, enjoy. But you can just index into it because now it's a class.
Okay.
Nice. Real-time code support. Love it. Was that it for Doug? For now?
I'm going to be out. I'm going to drop off and be playing with this. So,
okay. Carl, you had an update.
Okay, give me maybe on to the next person. I'll get mine ready.
Okay, you were the last one I had on the call, so why don't we jump into open mic for anything that anyone's discovered, and when you're ready, just jump right back on in, Carl.
All righty. Yeah.
I've
Never
got a
mind.
question for Ted. Let's see if he's golden tonight.
Okay, I think I have a one question limit, but
oh, just the one question. Oh, boy, I better phrase this correctly then. Have you ever used the RoboClaws?
Yes.
Yes. Okay. I suspect maybe one is going out or something. I read the encoder values like, you know, every 50 milliseconds.
Right.
You know, usually I I do like an Excel speed command and then just let it run and then look for the encoder counts to be a certain value. And then, so I use that in moving backwards and forwards, just rotating some number of degrees or rotating to a heading that I get off the BNO 055. Anyway, I don't know if I inadvertently harmed the little sucker, but I'm getting more and more zeros for encoder counts as time has gone on. So it, you know, and it's a little weird. I can do, I can stick a print statement in there and see how many times it's zero. And the, sometimes there's 2 zeros and a valid reading or 3 zeros and a valid reading, but I get enough, you know, or at least I was getting enough valid readings to have it still work, although it's a little, I get a little bit of overrun, but that's okay. But now it's all zeros. So any idea? I'm kind of thinking there's something wrong with the RoboClaw.
Yeah, or the encoder or the wiring.
Yeah, the encoder counts look good. They're off of Go Build 'Em Motors.
Okay, yeah.
Yeah, so they're really solid. At least it seems it. Yeah, I've got another processor programmed. It's one of the Wemos Low-Lin lights, or Low-Lin 32 lights, I guess is the right name. Anyway, I'm gonna swap that out. I'm only using 7 pins on the processor, so it's not, you know, 2 for I2C, 2 for serial, 2 for the bumper switches, and 1 for the OpenMV H7. So those are my 7 connections to it. So there's, you know, not that many connections to it. But, and I have another RoboClaw. I'm going to swap that out and see if it kind of follows the one RoboClaw. But it's a weird one. It you know, the code was working fine, and now it's getting worse and worse.
Yeah, I had a problem with mine about a year ago, my RoboClaw, where it was occasionally just wigging out, like I'd be sending it a constant velocity, and it would suddenly jerk forward quicker and then stop and then go back to where it was going. And I ended up just reinstalling the firmware on it, and that seemed to have cleared it all up. So you might try that.
Oh, okay. Yeah, that's an idea. So you may be 2 for 2 here. So that's pretty
Yeah, I
good.
won't count on it.
He could be on a streak. If anybody else has any other questions, Ted's your man, I think, you know.
Carl, do you have something?
What?
I was asking if Carl has something.
Okay.
Please,
Anyway, I appreciate the help. I'll try that. I didn't think about that, but yeah, it could be.
It's fairly easy
That's
to
scary if firmware can. It's scary. If
Right. You
firmware
can do it in
get corrupted.
their IDE or whatever you want to call it. Yeah. Okay, cool. I'll look at that. Is Mr. Carl ready?
I see lights on his robot.
Well, we'll see how well this works. I'm going to try a kind of dorky share I hadn't tried before. And hey, it looks like it even has a chance of working, kind of, sort of.
Cool.
So yeah, so when last I had this beast out, and this is my outdoor robot, basically, such as it is. And when last I had it at that Saturday meeting, I couldn't get it to work quite right. And it was a kind of a lousy demo. And earlier in this call, it started to work correctly, and then it stopped working again. So what I discovered, so I was going to, where do I start? So when I left last Saturday meeting, the idea was to replace the soft servo with, one of these proper servo things or PWM modules. So I went to figure out how did I wire this, how on earth was I going to do that, and I wound up realizing that I had really crappy wiring, and I didn't know how I had assembled this, and this is duct tape and baling wire for a reason. So last night I rewired it, and it started to behave better. And I also read through the code, and I figured out what it's supposed to do. That's always a good sign, is having some idea of, like, what are you looking at? Does it have the chance of working or not? Because the last I touched anything on it was a year and a half ago. Or more, 2 years ago. So what I found was that, let me hit stop on this. Okay. So what you'll see up here is that I have this this reticule kind of thing that shows where it detects a cone, and I have this really annoying buzzer that sounds when it sees a cone in line. So so as we bring the cone in line, so you'll see that a few things. You'll see over on the left here, I have this is the data packet I send over serial from the OpenMV cam down to Arduino Mega. So we're watching it in real time, and this is the part that I thought failed 2 years ago. I thought I had a bit drop so I got a false cone detection that made it across. So I did some really kludgy thing to send a bunch more bits, and a bunch would have to be wrong for it to false error on false detected cones. So this is showing pretty consistent 0, and you'll notice that as I swing the camera through, it detects the cone, and then there it is. Like on the left-hand side, it's 120 degrees to the left. As I bring it towards the center, I get closer to 0 degrees. As I swing it towards the right, so I get like 120 degrees. So that's good. And then the next bit is so that seems to be coming across the port correctly now. So now if I turn on the PID loop, so let's say we aim at the cone, and the camera is kind of blown out, so it won't show so well. But if I turn on the cone, yeah, it's just the brightness is way off. Not much I can do about it. But I have these lights here that show it's aiming towards the center, and if I do that, the error correction says steer left. This blue light comes on. And if I go that way, the error correction here says turn right. So I got that much working. But the problem is you hear all this chatter in the background. And I think this is reaffirming that I really need to do something about that servo module, because I think there's too much going on that's screwing up the soft servo. So if I like turn on the motors, it's going to misbehave badly, I think. Well, let's see. Yeah, the steering servo is not working right. So I know it's computing right and it's doing everything right except the soft servo library isn't working. So that means I have basically 3 days to replace the soft servo library with a PWM module, and then I have a chance, maybe. So how's that for a rambling up?
Can you replace the software with hardware and use a hardware servo?
Well, that's what I discovered. So I was going to use this hardware servo PWM thing, and then when I started looking, I had to dig into this disaster of a wiring in here to figure out what I had available, and that's when I realized that way back when, 3 years ago, when I started this half-baked thing, I avoided using PWM pins because I thought all the timers were used up already, because those were the timers I'd used in the original robot. But I don't use those timers in this robot, so I think I have the PWM pins available. I just need to change the library out, I think, and recalibrate. I don't know. We'll find out.
Soft servo in a heavily loaded Arduino sounds like a recipe for trouble.
Oh, I think it's a solid recipe for big trouble. Yeah. Yeah. Yep. And the funny thing is, it's squirrely, so sometimes it just happens to work. Other times you can forget that. Most of the time. So we'll see. That's my target now for the next few non-working hours that I can steal away somewhere.
Good luck, Carl. We're rooting for you.
Upon us at Steve's place. So
What'd you say?
Things that are squirrely, you know.
Oh yeah. Well, I'm trying to get the squirrely stuff gone from here. I mean, it's bad enough here. And it really helps when there's no time. But this has been a nice distraction, so that's good. My 2 hours a year of robot building, we'll see what happens. Oh, there was another cool thing. So in a way, I forgot to mention this. Part of dusting the robot off and bringing it back to life, I noticed that the batteries I've used for a few years might be a wee bit puffy.
Ooh.
Yeah.
So I don't like puffy batteries, so I got new versions of the batteries, and I thought I'd try something different. So those were the regular 25C, and then there's only a couple dollar increase, but these are so-called nanotech. I guess they have a different construction in there. They're 50C, but they have a slightly different something, and I don't know. We'll see if they're any more robust. I thought I'd get one of each just because, you know, if we're going to throw variables in the mix, we might as well have as many as possible.
Yeah. Yeah, my batteries are getting old too. It's I've got 4 of them. 2 of them have one cell that doesn't work anymore. So instead of a 4S, they're 3S's.
Yeah.
And they seem to just short out. So I haven't taken the shorted cell out, and it seems to pass current through it fine. So
Don't do that.
don't do that.
I admit I don't really notice that my batteries get puffy until I buy new ones. I bought a couple of new batteries for this robot a few weeks ago, and my God, are they nice and rectangular?
Yeah, it shouldn't be like a cushy pillow. That's bad.
They feel like a brick.
Yeah.
They're very nice.
That's all I got.
All right, back to open mic.
I guess I was wondering, has anybody worked with any like LoRa modules or like SX 1280s in particular, like the e-byte ones or anything?
Did you say LoRa? Like
Yeah,
long
like
range
the
radio?
little, yeah.
Like the LoRaWAN, WAN.
Yeah, I think so,
Yeah,
yeah.
I kind of played around with them. I still have, basically it's a converted riding mower that uses, I can hit a switch on a remote.
Are you using an Arduino to talk to the module or?
So that's my
Okay,
two joystick
okay.
remote. And
Okay.
there's a little switch in the front of it here that I can, if I turn it on, basically I can take over the mower and steer it. And
Okay.
then I
put it. That's using Arduino for your microcontroller on there, or?
No, it's actually an ESP32 with LoRa on
Okay.
it. And
Okay.
it goes pretty much, it would go like at least 1,500 feet
Okay. Okay.
without any issue. And I was actually inside. I had my wife drive around the property to different areas, and I was writing down what the values were, and she was telling me where she was, and with you can get in a received signal strength indicator out of LoRa.
Okay. Yeah, because I was trying to get them to work, but I was trying to use a Pi, like a Raspberry Pi, but I could not get them to like link up for some reason. So maybe I should just try a microcontroller instead then.
Yeah, the ESP32 with I forget which one this was, but it also had a little display inside. Let's see if the battery is still working. Nope, battery's dead. Oh well, or I may have taken it out of the case here. Oh, nope. There we go. Anyway, so I don't know if you can see it in there. There is a little display.
Yep.
It tells me what values I'm sending for the left and right wheels. And when these little joysticks don't end up with, exactly on center. So whatever it wakes up as, if I hit the switch in the other direction, it uses that as the 0 value. So, and it tells me, how many packets it's sent. So anyway, pretty handy. And the LoRa worked, for low bandwidth stuff, worked really well. So
Cool. Okay, thanks.
I think you can get it to go much further, distances, but I didn't need it to go that far. It was just kind of 1,500 feet. 1,500 feet was far enough. Well, I would say if Scott's robot works as well as it did in his demos, he's definitely going to kick everybody's ass. So, as he would say. So,
we shall see. Many things can go wrong on the day
that's
of.
true. That's true. He can self-sabotage, drop a screwdriver in, on his processor board, short the whole thing out, and be fighting those demons. So.
Kareem, thanks for your suggestion about looking at the UBX proprietary codes from my GPS receiver. I see what you meant about the difference in digits.
Yeah, they make sure that you get all of the digits that they can reliably provide.
Yes, and the standard for NMEA is only 6 digits, and there's 8 coming out under UVX. So I'm looking at the code I'm using, which is Peter Hinch's GPS receiver code, to see what he does and what it'll take to modify his code to receive the UVX sentences. But that's an excellent point. Thank you.
You can also configure your receiver to output a more higher precision NMEA.
Okay, I'll look at that. I have the UCenter. I have the UCenter software running now with my 6Ms, so I should be able to see what it is and reconfigure it.
You can definitely get 8 digits out of UCenter, out of NMEA. At least
Yeah, well,
again, on
that's
the later
good.
generations. I don't have a 6, so I don't know.
Yeah, that's why my NMEA reference sheets are old, so I want to see what Peter Hinch actually wrote in his MicroPython code. I'm using his version of the driver because it runs under UASync. We'll see. Thank you. Anyways, good points. I'm familiar with the Euclidean approach towards navigation. I just didn't expect to have trouble with the Habersign stuff.
Well, guys, it's about past my bedtime, so I'm going to drop off. Looking forward to seeing everyone next weekend.
Mm-hmm.
Thanks, Steve.
Wish I could be there.
Appreciate you hosting it.
Yeah.
Good to see you.
Good to see
See you
you.
next weekend.
Hey, Steve, what's the, when was the last time you mowed? Is your grass really short, or is it,
I called the guys and I said, come out and mow on Thursday. So
Oh, wow. Okay.
fresh mow.
Great.
Yeah.
We need a fresh pile of monkey balls for Ray too while you're at it.
Yeah. You'd be happy though. The horse apples are gone. I'm going to put some other obstacle out there for you.
Oh, I thought maybe you'd have them in a box that, fell out and then just scattered in the path or something.
Yeah. I'll put
I
some
take
hay
a
down.
long, hard think to see if Steve's robot works well in long grass, because he may be fooling you.
That's right.
That's true. Didn't specify what the actual height was, but yeah.
Or if it was going to be mulched or bagged.
Correct. All right, guys. Have a good one.
See you, Steve.
Good night.
All right.
I'm not sure if anyone else is using MicroPython besides me, but I would probably mention another interesting glitch that I found in my use of async IO with MicroPython, which I feel is a really good, simple multitasking procedure. The people who wrote it also recommend a profiler that they put together in order to monitor how well async IO is doing its very simple time sharing and the execution of the various coroutines that you configure. I'm using about 5 coroutines now, and I wanted to profile them. So I downloaded and installed the profiler and got very useful information from it. And then proceeded to write some more code and play some more games or play some more testing. And then I started to realize as my robot sits here on my workbench that, every few minutes the servos would glitch a little bit, just a little tiny bit. And servos are glitchy anyway, so I just put it on my list of interesting things to look at later until I realized that it's actually resetting itself every few minutes. I had no idea why. I started to research the glitching problem and finally realized that the thing is outputting a crash dump every time I hear that glitching noise, and that it's crashing every several minutes. It's doing a really beautiful auto restart, and my code and their code is good enough that you don't really notice too much when it resets if you're not doing anything else. I had no idea what to do with the crash dump. They have a procedure for looking into it that's way beyond me. And besides the crash dump, it doesn't tell you anything else that's happening except it crashed. So Pragmatic Diagnostics says, start going through the list of all the changes you've made in the code in the last week and start removing them one at a time. So I did that. And finally, I deduced that the thing that was crashing it was the profiler code. It turns out that the profiler code would crash my executing application exactly every 75 seconds. Take the profiler out, actually comment it out, and it stops crashing. So something worth knowing if you happen to be involved in using MicroPython and its async IO functions and its profiler. The profiler is great. I'm really impressed by the tool, but you can only use it for short periods of time. Certainly, well under 75 seconds. I'd originally used it with 10 or 20 second runs, so I never saw the problem when I was profiling. But then I just left it in and left it running foolishly, as it seems. It does not protect itself. I suspect it fills up the heap and then it crashes.
It's much better if it occurs on a regular basis versus random or very seldom, you know.
It's when I started to time those little glitches of the servo that it became obvious to me I better fix this.
So many bits of test things do that, right? You need the test equipment, but you can't have it.
Well, it was interesting. Like I said, the profiler is great. I like async IO a lot. I originally wrote my little Wander test program was originally written as a state machine running as part of the subsumption loop, the very basic loop that I was running. And it had a hell of a lot of wait states in it because I don't have a speed regulator. So in order to get the robot to back up for a certain distance, I would simply make it back up for a certain time. When I wanted it to turn 90 degrees, that's a timed turn since I wasn't using anything else to do it. So I had a whole bunch of states that would simply do timing. And I thought, this is dumb. I'm going to have to, consolidate all these things. And then I realized the async IO is designed around timing. It's designed around programmable sleep functions. So I rewrote the thing as a coroutine, and all of a sudden it's only got 1/4 as many states in it, and it runs like a charm. And it's much easier to understand, and much shorter. So again, another win for the way this async IO works. It's a very nice, simple multitasking mechanism.
Would y'all like to see another robot?
Absolutely. We love looking at robots.
Okay, 1 second here. Can't see.
Are mushrooms involved in this one, or?
I can't tell you that. Trying to get my. Okay, can you see my screen?
Yeah. Hard to pilot.
Yeah. So I decided to go a different route with this and try out the ArduPilot. So the last week I've been playing with it, and last night I made this little map around the neighborhood, or partially around the neighborhood, and I got it to work. Got it to go halfway around, or about 3/4 of the way around, and then one of my wheels fell off. So that kind of ended that. So tonight I tried it again, and this is just a little video of it going to the waypoints. Now you'll see there's a fire hydrant right there. Well, for some reason I hit that fire hydrant, so I had to pull back over and rerun it, and then it veered off into the street. Come to find out later, my GPS had come loose from the robot and was dangling over upside down, and not in a really good condition.
Amazing, it still worked.
Yeah.
Cool.
It's running. It doesn't have very good performance, and I think it's partially due to the ECSs. I had to change them out for a different ECS, And then the ArduPilot also detunes you can set parameters for your speed and so forth. So I need to do something here. This is a video I took last year before I changed out these. And you can see it's got pretty good power there, but I'm not getting anywhere near that much power now.
Are you sharing a video or something? Because we're just seeing the ArduPilot map.
Oh, sorry about that. Okay. I wonder if I have to. Can you see a robot in the middle here?
Yep.
Yep.
Okay. Yeah. Okay. So this was tonight's run with the
Robots at night. I like it.
I can't get it to run. I don't. Let's see. Wait a second. There you go.
Oh, there's the fire hydrant you talked about.
Yeah. Yeah. So I decided it needed to go a different course following the GPS.
Robots in the street at night. Sounds great.
I like it.
But I was going to show. Yeah, so this is the same robot last year with a different electronic speed controller on it. And as you can see, I've lost quite a bit of performance on it. So I need to figure out if it's ArduPilot or if it's a speed controller or what has decreased the performance of it.
Oh, that's running pretty good.
Yeah, that's the way it was last year. This year, it's not as fast and it doesn't seem to have as much torque.
That's very nice.
Yeah.
Is it 4-wheel drive?
Yeah.
So does it have 2 motors, or 1 motor per wheel, or?
It's got 1 motor per wheel.
Hmm.
Yeah. So I don't think I'll be able to compete this weekend, but I may bring it out just to see how it handles the terrain.
Yeah.
Well, if you can skip over rocks, I don't think Steve's property will be a problem. It's mostly grass.
Yeah, that's what I was thinking last year, but this year with it not performing as well, it's it's kind of a dog right now. But I know inside of ArduPilot, there's settings you can do, like PID performance, and then you can also control the rate of the turning and so forth. So a lot to learn yet.
So what's its ground clearance? It doesn't look like it's got a lot.
No, these wheels are about 4 inches, so it's only got about 2 inches of clearance at the most.
Okay. But it went up and down curbs okay.
Yeah.
Interesting.
Yeah, we'll have to see if 4-wheel drive and torque can handle all the bumps and so forth.
Now, what size is that robot chassis? Do you know what your wheelbase length is?
It's about 12 inches.
Yeah, okay.
Oh. Okay, so that's bigger than it looks.
Yeah.
Yeah, yeah.
Hey, David, I dropped out for a while there, so let me ask you quickly, which pilot are you using? Is it Pickhawk, ArduPilot?
I am using this here for the flight controller.
Okay, that's cool.
Yeah, I thought there's a guy online that has he uses a controller similar to this, and then he attaches a Raspberry Pi Zero to it
Mm-hmm.
to do some controlling and autonomous work through it.
Mm-hmm.
So that'll be my next step. I've got the Zero on it. I just haven't got to the point where I can do anything with it.
Cool. That's nice. Really nice.
Yeah.
I played with one of the older ones, and I was able to make it drive to all the cones, but obviously I didn't have enough skill to have it stop and hit the cones. But it could be done. It was just my knowledge. But I did get to all the cones, so it's a viable. The reason I didn't like it was really because there's a lot of you have to be kind of linked to Mavlink, and you have to have the mission planner running, and which is great for a lot of reasons, like you can get your telemetry and all of that, but it can be tricky when you're in the field and you just have to set it all up. I don't know now, maybe it's easier.
Yeah. What I was doing is I was just downloading the waypoints from my laptop into the robot, and then I would just leave it booted up and I would take it outside. So I didn't need to have the laptop with me.
Mm-hmm.
But getting it downloaded, like you're saying, is still a bit of a challenge, I think.
Mm.
Now I haven't. They've also got a cell phone app that I haven't messed with yet. So I'm not sure if you can just possibly upload it from your cell phone.
Yeah. Well, you can load it, on a radio link. So I'm sure you could do it on a cell phone.
Mm-hmm.
It is possible to do all of that. I mean, it's really very flexible system, but you do have to kind of like set it up from Mission Planner to start with. But that's not, it's not a big thing. I'm just saying.
No, and there's the guy that was showing how he set his up with a cell phone through a cell phone tower. So he was actually transmitting from 70 miles away.
Hmm. Do you know if they have an app that's a Mission Planner app? That would
Yes, they do.
Okay. See, they didn't have that when I was messing with it.
Mm-hmm.
That would be a big help.
What's the cost of the unit?
The Ardu Pilot?
Yeah.
Well, I guess what you're showing on the screen here.
Oh. All those parts are 3D printed. A guy from Czechoslovakia had the models, so I took them, and it's got the motors were like $15 a piece. The controller, that was the pricey thing. It's about $65.
That's not too bad.
Nope. It's very viable method of doing it.
Very cool.
Yeah.
Yeah. Oh, do I get a gold star?
You get a gold star.
All right.
Gold star for David.
All right. Well, we'll see if I show up Saturday with or without a robot.
Good luck. I hope the robot gods smile upon your robot.
Oh, that would be nice.
It smile upon us all.
Really.
David, you are going to compete. I mean, if you've got it going that good, there's no way you couldn't get a point, and you could probably go for the whole shebang.
Well, like I was saying on the YouTube video, I had different electronic speed controllers on there, and the performance was much better.
Yeah.
I switched it to other ones, and that plus the way the Ardu rover's set up, it's cut the performance considerably.
Yeah.
So I need to get it tuned up.
Yeah. But you could definitely compete. I mean, like I say, I'm sure you can drive to 10 feet of the cone, right? I mean, that gets you 1 point, gets you a mug.
Well,
Yeah.
that's kind of what I'm hoping for is 1 point.
Okay. We'll see you there, David.
All right.
All right. What else have people seen? I saw some cool videos come across Video Friday. Let me just share this one. It's pretty neat. Where is it? Yeah, this one's good. I'm not sure how well this will play, but we'll give it a go. Hello, is this showing?
Yep.
Okay. Okay. So this is I think this is the.
Yeah.
The author commented that there's probably a human driving it, but just even so, it would be autonomously self-balancing, and it would be doing the low-level control, which is like really impressive. And robust.
Well, we won't ask how many attempts it took to get some of these videos.
Yeah, right.
I'm sure there was never a twig that got caught in the wheel. Never.
Yeah. Or a wheel that just happened to get caught between a root or something.
Yeah.
Is that a Chinese company? Links?
Don't know. Links.
Ed, I posted a link in there to the Ardu pilot, the rover portion of it.
There was one other that I thought was really interesting and relevant to this group's interest. So let me. You guys probably aren't getting the audio from these, right?
Yeah.
That video that I played, were you getting audio from it?
It didn't seem like it.
Okay.
No.
then never mind. I won't play this one because you kind of need to. Well, maybe I can paraphrase what the guy is saying because it's really pretty impressive. It's a the guy's talking about understanding the environment, how deep learning is used to understand the environment. He's talking about how the 5 cameras on it are the primary means of data input, and how the problem that they're trying to solve is how it can know what it could stand on. Things like wires are problematic because they're hard to see. It's hard to understand like what their movements be in response and then here like it could be a platform, but how does the robot know it's got wheels on it and it can flip and show yeah. So he's talking about how the cart shoots out and it falls over, and how does it know that that could happen? So they're working on integrating large digital foundation models using something equivalent to large language models, except for video of understanding the world and relating videos to each other, but trying to identify real world things, so it can like better understand what it should and should not step on. You know, like it's okay for it to step on a platform and a stair, but not wire or a
banana peel. No stepping on banana peels.
Right.
Or walking
Right.
under ladders because
It's really-
everybody knows that's bad luck, you know. So.
That's what the video is, the audio, the video is really all about, is talking about how this group is trying to develop very large models of the physical environment so that the robot can really understand the environment in a much deeper way than is possible today. So I thought that was like, wow, really interesting. Anyway, that was all I had on that.
So what does a Boston Dynamics spot robot go for these days? With inflation, it's probably up to, 120K. It was like 80K or something, I think.
Well, anyone else got anything? Because I feel like the energy is subsiding and it might be time to call it a night.
I think that works.
Thank you very much, everybody, for helping out.
Yeah, and thanks guys for coming, and good luck everyone that's working on robots with getting them working by Saturday.
Yep. Pray to your favorite robot god.
Take care.
Sounds good. Good night.
Hey guys.
Good night.